8.2. Identify and apply security controls in software development ecosystems. Alright, so this task we're going to cover a number of subtasks that cover concepts such as programming languages, libraries, tool sets, and more. So if I don't go deep enough, you know what to do. Get that prompt at the end working for you. Alright, this task has 9 subtasks. We're going to be covering programming languages, where we discuss how to choose secure programming languages based on project requirements and the importance of secure coding standards. 2. Libraries. This subtask focuses on the importance of using trusted libraries, regularly updating them and conducting security assessments before integrating them into your project. Tool sets. Here we look at the comprehensive development tools you should use, including IDEs, version control systems, and testing frameworks with a focus on security. 4. Integrated Development Environment, IDE. We'll explore how to use IDEs efficiently and securely, leveraging built-in tools, plugins, and extensions to enhance productivity and security. 5. Runtime. This subtask covers securing the runtime environment, including applying patches and monitoring performance for any security risks. 6. Continuous integration and continuous delivery. CI/CD pipelines are crucial in modern development, and we'll discuss how to integrate security checks into these processes. Software configuration management. We'll talk about version control, baseline management, and how to ensure transparency and accountability through proper change tracking and auditing. Code repositories. This section emphasizes the importance of secure code repositories, access control, branching strategies, and ensuring backups. And 9. Application security testing. We'll cover various security testing methodologies like static application testing, dynamic application security testing, and interactive application security testing. Each of these subtasks plays a significant role in the broader goal of securing software development life cycles. These topics may overlap with other areas, but remember, repetition is by design. It reinforces those very important principles. 8.2.1. Programming languages. When developing secure software, the choice of programming language is critical. This subtask focuses on understanding how programming languages impact both performance and security. Language selection criteria. You need to consider the requirements of your project, things like performance, security, and scalability. When choosing a language, for example, compiled languages like C and C++ are converted directly into machine code, making them fast, but also prone to certain vulnerabilities like buffer overflows. Interpreted languages like Python and JavaScript, while easier to use, can introduce security issues due to their line-by-line execution. Secure coding standards. Once you've chosen a language, it's essential to implement secure coding standards. These are sets of best practices that help prevent vulnerabilities like injection attacks, buffer overflows, and other problems. For the exam, you'll need to know how these standards vary based on the language. Language-specific security tools. Each programming language has its own set of tools that can help identify vulnerabilities early in the development process. These include static analysis tools tailored to the specific language you are working with, and ongoing language maintenance. Lastly, keeping your programming languages and their associated libraries up to date is key to minimizing exposure to known vulnerabilities. 8.2.2. Libraries. Libraries play a crucial role in software development by providing pre-written code that can save time and promote consistency. But they can also introduce security risk if not handled properly. Here are some things you need to focus on. First, the definition of a library. A library is essentially a connection of pre-written functions that developers can call upon to perform common tasks. This saves development time and ensures consistency across different platforms. Trusted library sources. It's important to only use libraries from reputable sources to avoid inadvertently introducing vulnerabilities into your project. For the exam, you should be able to identify how third-party components can create security risks. Regular updates and patching. Just like with programming languages, keeping libraries up to date with the latest versions and patches is essential to mitigate security risks. And security assessment of libraries. Before integrating any library into your project, you should conduct a security assessment. This includes reviewing the code, checking for vulnerabilities, and making sure the library meets your organization's standards. 8.2.3 Toolsets. In software development environments, the tools you use can greatly affect both productivity and security. This subtask focuses on ensuring that your toolset supports secure development practices. This includes comprehensive development tools. A well-rounded set of development tools should include everything from integrated development environments, IDEs, to version control systems and testing frameworks. These tools help streamline the development process while ensuring consistency across the lifecycle of software. Security-focused tools. It's important to integrate security-focused tools into your development process. These tools, like static and dynamic analysis tools, help identify vulnerabilities early, during the development phase, before they become bigger issues in production. Regular tool updates, just like with libraries and languages. Keeping your tools up to date is essential. This ensures compatibility with development environment and reduces the risk of introducing vulnerabilities from outdated tools. Tool integration and compatibility. Finally, it's essential that your tools work well together. A disjointed tool set can lead to inefficiencies, which can in turn result in security gaps. Ensuring your tools are compatible across the development, testing, and deployment phases is critical for maintaining a secure and efficient workflow. 8.2.4 Integrated Development Environment, IDE. This is where much of the action happens during software development. It's important not only for productivity, but also for maintaining security throughout the development process. This includes centralized development platform. The IDE provides a centralized platform where developers can write, debug, and test their code. The centralization enhances productivity as everything is in one place, but it also presents security risks if not properly configured. Built-in tools and extensions. IDEs come with built-in tools such as code editors, debuggers, and version control integration, which simplifies complex tasks. However, you should also incorporate security-focused extensions and plugins, which can help identify potential vulnerabilities while you're writing code. For the exam, knowing how these tools can enhance security in real time will be key. Customization and configuration. Every team has unique needs. IDEs can be customized accordingly, whether it's configuring themes, shortcuts, or security settings. Ensuring the IDE is optimized for your workflow improves both efficiency and security. Scalability features and plugins. Many IDEs offer security-focused plugins, such as those that provide code analysis or check for vulnerabilities as you write code. Leveraging these features helps developers address security concerns in real time instead of waiting till the testing phase or later. 8.2.5 Runtime. This refers to the period when an application is actively executing on a system, and securing this environment is crucial for both performance and security. Definition of this is the runtime environment manages resources like memory and CPU, handling errors and ensuring that the program functions as intended in its production environment. For the exam, you'll need to understand how runtime security is essential to maintaining the integrity of a program while it's running. Runtime environment security. Keeping the runtime environment secured means applying the latest patches, restricting unnecessary privileges, and monitoring for any abnormal behavior that could indicate a security threat. These practices are critical for maintaining security throughout the program's lifecycle. Performance optimization. It's not just about security or confidentiality, right? It's about availability. So these environments need to be optimized for performance as well. Efficiently managing memory and CPU resources ensures that the application runs smoothly and meets performance expectations. Runtime monitoring and logging. Comprehensive monitoring and logging are essential during the runtime to detect any errors in real time. This can include monitoring system performance and identifying security threats. 8.2.6 Continuous integration and continuous delivery. These are pipelines that have become an essential part of modern software development, ensuring that code is built, tested, and deployed efficiently. From a security standpoint, CI/CD can also help us catch vulnerabilities early and ensure that security is baked into the entire development process. This includes automated build testing. Continuous integration automates the process of building and testing code with each change. This ensures that errors or vulnerabilities are detected early before they escalate. Seamless deployment pipeline. Continuous delivery automates the deployment pipeline, allowing for rapid and reliable release of updates or new features. Automation minimizes the risk of human error during development and ensures that the code remains secure as it moves from development to production. Version control integration. Integrating CI/CD with version control systems ensures that changes are tracked and managed efficiently. This integration not only helps teams collaborate more effectively, but also provides a security layer by ensuring that all changes are tested and reviewed before they're deployed. Security in the CI/CD. Incorporating security checks into the pipeline, such as automated vulnerability scanning and compliance validation, is essential to catching security issues as part of the continuous development deployment process. This ensures that security is an ongoing concern, not something that's added in after development. 8.2.7 Software Configuration Management. Effective configuration management is crucial to maintaining the integrity, security, and reliability of your software throughout its lifecycle. And here are some things you need to focus on. Version control. Implement a version control system that allows you to track changes to code, documents, and configuration files. This ensures that modifications are recorded and reversible. For the exam, you should understand how version control contributes to a secure development environment, especially when managing multiple versions of the software. Baseline management. Establishing and maintaining baselines is essential for consistency across development, testing, and production environments. Baselines serve as reference points that allow you to track changes and ensure that the software remains secure and stable. Change tracking and auditing. Software configuration management tools enable you to track and audit changes made to the software. This is crucial for transparency and accountability, ensuring that every modification is documented and can be traced back to the individual or team responsible. Automated configuration deployment. Automating the deployment of software configurations reduces human error and ensures consistency across different environments. It also streamlines the process of rolling out updates or rolling back configurations when necessary. 8.2.8 Code repositories. These are essential for managing and securing your source code. They centralize code storage, allowing for teams to collaborate efficiently while maintaining security and version control. This includes centralized code management. Code repositories provide a centralized location for storing and managing source code, ensuring that all developers have access to the same version of the code. This is key for maintaining consistency and avoiding the risks of fragmented code bases. Access control and security. Implementing strict access control measures in your code repositories are essential. Only authorized personnel should be able to commit, modify, or view code, which helps protect the project's integrity and confidentiality. Branching and merging. Repositories support branching and merging strategies, allowing multiple teams to work on different features or bug fixes simultaneously without disrupting the main code base. These strategies help keep the development process organized and secure, ensuring that code can be integrated smoothly. Continuous backup and recovery. Regular backups of code repositories are vital to preventing data loss. You should also have a recovery process in place in case there's issues like accidental deletions or system failures. For the exam, knowing the importance of backup and recovery procedures in a secure development environment, critical. 8.2.9 Application security testing. One of the most critical steps in the software development process, as it ensures that your application is free from vulnerabilities before being deployed. So you'll need to know that these different types of tests. Static application security testing, or SAST. SAST involves analyzing source code or binaries without actually executing the program. It helps detect vulnerabilities early in the development phase, such as any input validation problem, buffer overflows, code injection. This is important because fixing issues at this stage is far easier and less costly than addressing after deployment. Dynamic application security testing. DAST evaluates a running application by simulating real-world attacks to identify vulnerabilities that could be exploited during runtime. It's essential for catching issues early, and that only manifests when the application is live and running, such as other input vulnerabilities or improper authentication. Interactive application security testing combines elements of both SAST and DAST. It analyzes the application while it's running, but with a deeper understanding of the code, giving a more comprehensive results. And finally, software composition analysis. SCA focuses on third-party libraries and components that are integrated into your application. It identifies known vulnerabilities and ensures that you're in compliance with licensing requirements. Given the increasing reliance with the open source components, this is very critical for maintaining a secure software ecosystem. Let's quickly summarize A2. Identify and apply security controls in the software development ecosystem. We talked about program language selection, choosing secure programming languages based on project requirements, and implementing secure coding standards to prevent vulnerabilities. Library and tool management. Utilize trusted libraries and regularly update them to your development tools, and make sure that they're both updated and integrated with security-focused tools for continuous monitoring and protection. Integrated development environment. Use an IDE that enhances productivity and incorporates security plugins or features that catch vulnerabilities early in the development process. Runtime security. Keep the runtime environment secure with regular patches and by monitoring for performance or security issues while the application is running. Continuous integration and continuous delivery, CI/CD. Automate build, testing, and deployment pipelines with CI/CD processes, integrating security checks at every step to catch vulnerabilities early and maintain system integrity. Software configuration management. Implement version control and baseline management to ensure consistency, and use automated deployment processes to reduce human error. Code repositories. Secure code repositories by enforcing strict access controls, regularly backing up the code, and using branching strategies to keep development organized and secure. And application security testing with methods like DAST, SAST, and I don't know how to say IAST, as well as SCA to identify and address vulnerabilities throughout the development lifecycle. All right, you know what to do on the next slide. Yeah, give it all a go. Again, I hope by now you're very comfortable with adding, deleting lines, whatever, tweaking it. I really expect that at this point you guys have saved your own prompt that you like better than the one I have, or something like that. I did some neat ones too where I could have it track my status, so you might want to play with some of those too. Say, can you keep a track of my status and how I'm doing, and let me know if I'm weak in one particular domain or something like that, and suggest improvements. So play around with it and have fun. All right, see you in A3.